All right, everybody. So today we're going to look through some more notes of line of best fit and scatter plots. So this is some geo that Mr. Dano made and shared with me, and then some questions that we're also going to do today, which will be pretty good. So let's start with defining what a scatter plot is and a line of best fit is. So a scatter plot is simply a way. Make sure you copy this down to display a set of data. So later in today's sub work, you're actually going to make your own. I'm going to have you collect some data so that Friday you can continue to work on Desmos. So that's also happening in today's lesson. You're going to, after we do some of these um, graphic organizer notes, I'm going to show you. And if you're with Mrs. Brown, she'll walk you through it. But how to actually, I want you to try to follow along with the video and make your own Desmos scatter plot and how you can get the accurate, exact line of best fit. Because sometimes when you make a line of best fit without technology, it's really just kind of a guess and an estimate. So, speaking of line of best fit, let's write down the definition for that. So, basically, it is a line that goes through a set of data points, sorry, to best represent the data. So how do you best represent it? Is you try to keep the data points balanced on both sides of your line. So try to keep data points balanced on both sides. All right, so let's kind of look at some differences between positive, negative, and no correlation. So I think we saw this earlier in the week in other videos, the eHow video. So positive correlation, very classic example would be like the more you hours maybe studying, and then maybe your grade. So usually, the more you study, the more improved your grade would be. So scatter plot like that, you can just kind of like do something like this on yours. It's the points are pretty close together. It's pretty correlated, and it's positively correlated. There's a strong correlation. The more you study, your grade goes up, and you'd make a line of best fit where you kind of want to have the same amount of points on one side as you do on the other. So, how about a negative correlation? Trying to think off the top of my head what would be a negative correlation. Maybe your bank account over time while you're on vacation. So this would be time. This would be your money on vacation. So maybe it goes like this, and then it comes down. Take multiple withdrawals in a day, and so you can see that you had a good vacation, and you have a negative correlation like that. So no correlation could just be anything really. So you just have a bunch of data points and you can't really say if it's positive or negative. Maybe it's something to do with COVID, like um, the time of the month, that like time and when people are getting COVID. I don't know, something that would just maybe there just wouldn't be any correlation in that. So the data points are all over the place. You can't really say they're really tightly together going upwards or downwards. Well, I just went over the next part of the geo without even knowing it. So strong correlation is, like I said, almost like really almost linear, but maybe a little bit off. weak correlation. You can still have a weak correlation that's maybe positive, where the points are, heading upwards, but they're kind of more spread out like that. So again, this is really strong, almost linear, but not exactly. This is correlated positive, and this is positive, but this one's just a little weaker. Okay, so on the next page, I'll do one of these for you. So looks like I want you to make a scatter plot and then describe the correlation, and then write an equation if possible. So let's do number 7 here. So we just put our dots here: 0, comma 4. No, 0, -3. My bad. 0, -3. 4, -2. 3, 0. 2, -1. 1, 1, 0, 1. Huh. Kind of a weird correlation. I don't even know if you would even say that's tightly correlated, unless I made some mistakes here. I don't think I did. So I don't know if I put a line through it. I'll try to go through the origin just so it's easy to write and I'm kind of doing it as I see it. There's a couple points up here. This one's a little further below. So I would say weak correlation. I would say it's negative. And if I was to write an equation, I kind of knew how to write this in mx plus b. So I kind of cheated as I was estimating. So it goes to the origin. I tried to make it a slope of down 1 over 2, down 1 over 2. So I was really going for y equals -1/2 x plus 0 for that one. Let me do one more. There's got to be one that's got a better correlation than that. Maybe this one's better. So -4, 7, put a dot, -3, 5, put a dot. This looks pretty correlated. -2, 6. Okay, now we're working with something here. -2, 3, -1, 4, 0, 2, and 1, 1. All right, so that's definitely tightly correlated. I do not have a ruler. Oh wait, I do have a ruler. It's like pandemic time all over again. That's where I kept my ruler in 2020. So, anyways, yeah. So I kind of want to have the same amount above and below. Kind of want to keep some type of. Hopefully, I get a pretty point, but I'm thinking maybe those two above, those maybe I don't know, something like that looks correlated. I don't know. It could have been a little bit different depending. Again, I'm going to show you how to do this on Desmos, where it's like it tells you you use this technology to give you the exact line of best fit. So, oof. All right. So I'm trying to look for some pretty points. Okay, if I had to really stretch a little bit here, maybe I could say this is a pretty point, and this maybe is a pretty point. I don't know. Well, let me see. I don't know. Let's say that's the other pretty point. So then my slope would be 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. -6/7 x, and then it looks like it's going through, I don't know, plus 2.3 maybe. Again, you could write that as a decimal. Depending on, none of you guys for this page are going to get the same, or it's very unlikely that you get the same line of best fit. But there's a couple examples, and then you can try number 6 and 8, either by yourself, with a partner. Mrs. Brown can do it with you, whatever's best there. All right, so this is the last page that I'm going to have you guys do. Trying to think. Yeah, if I don't, there might be a fourth page, but this is really the page I wanted to do with you and have you go through Desmos. So I'll do this example on Desmos with you, and then see if you can use Desmos. I'll put the link in the subwork. Do the fruits and energy problem. So thermostat shows the setting in units called gas marks. So on a British gas oven, and the corresponding temperature in degrees Celsius. So So your settings on this oven are 2 through 8, and this will be the temperature in Celsius because in Britain and Europe they use Celsius, not Fahrenheit. Okay, so let's do this on Desmos. So you're gonna go to Desmos here. Let me just reset a link so it's exactly the way it starts. So how do you add a table on Desmos? So what you do is you go to this plus sign right there, click plus, then you click table. Okay, now it comes a table. So now I can enter in the data. So 2, 3, 4, 5, 6, 7, 8 for my X's. And then for my Y's, temperatures are 150. I'm pretty sure it's going to be pretty correlated. It's not linear. I mean, what kind of stove wouldn't be going with this? Oh, it's a little different. I can already tell. It goes up 10, 20, 180, 190. So it's not 100% linear. 200, 220, and 230. Okay, so you might be like, where the heck are the points? I don't see anything. Well, that's because you have to zoom to fit, or you need to zoom in on it. So basically, what you'll do is click this button, and there's your scatter plot. You can see it's tightly correlated. Looks good there. Um, with the data you're going to collect today is going to be on a Google form, which then I can give you the data on Friday as a sheet. So it's even easier really quickly if I did it on a sheet. I'm just going to show you quick, just so you have it. So here, Google Sheets. So check this out. So just so you see it for Friday, you can just take the data and just copy and paste it. So 2, 3, 4, 5, 6, 7, 8. Then put the other numbers here really quick. 150, 160, 180, 90. Sorry, I can't do this much quicker. 200, 220, 230. Sweet. Now what you do is you just Command C, copy them, right? Go to a blank Desmos right here, and then Command V, boom, they're right there. And those actually zoom to fit around like automatically. I didn't have to press that button. So, anyways, we're both, regardless how you do it, this is your table. So, now if we go back to the page, if you want to, I guess we should technically put them in paper, right? This is taking a little bit longer than I expected, but hey, gives everybody some extra practice and some time to do stuff. So here we go. 2, 150, 3, 160. Ugh, I don't know, maybe right there. You got to estimate now. 4, 180, a little bit over that. 5, 190, a little bit below 200. 6, 200. 7, 220. And 8, 230. Again, you can see it's pretty tightly correlated. I made my line of best fit. I would just kind of I don't know. I hate doing it by that way. Like I rather just do it on Desmos. So, but I can describe the correlation. I would say it's a strong positive. Okay, so here's the cool part. So this next part says an oven set to 10 heats is to temperature of 260. Does this fit the trend line? Blah blah blah. So check out the cool stuff you can do on Desmos. So here we go. Try to follow along, or see if you can do this when it's your turn to do number 11. But here goes. So check this out. So what you can do, right, is you can write y equals mx plus b. But if you put in the subscripts x1 and y1, it will then automatically give you a line of best fit. So check this out. So y1, just literally typing y1. And then because I want approximately, instead of writing equals, I put the squiggly. And I could even show it to you here even easier. The squiggly line, where is it? Does it have it here? Oh, there it is. So if you didn't see that, I went here, and I went ABC, And then there's that squiggly line. So you're looking for that on your keyboard. So Y1 squiggly line MX1. So you can already see it's doing some cool calculations plus the beginning. Now we are good to go. So it gives us a perfect line of best fit, and it draws it for us, and it looks pretty good like that. Hold on, I think my daughter's coming over here. Brooke, Brooke. I thought I heard her coming to the door. Oh, it's like teaching in like the beginning of the pandemic all over again. All right. So anywho, here we go. Yeah, I just wanted to make sure the video is still recording because that would be horrible. So check it out. This is my trend line, right? Perfectly balanced, the same above and below. The spacing's perfect. So if I want to write the equation, right, I could just type it in the next cell. So I would go here. And I'm going to write y equals this time. The slope, I'll just round it to the nearest tenth. 13.6, 13.6 x plus, and then my beginning now is 122.1, 122.1. All right, so basically the red line just went over the black line because there was just a little bit of rounding. And then there's a couple ways you could then answer that question in part C. At mark 10, so if I go here and I click on the line, where's 10? I have to go all the way up here. I can go almost at 10, right? Won't do perfect because, oh, that was pretty close. 10 says 258 uh, 236. So that's pretty darn close. If you want to see it in the table, this is pretty cool too. So what you can do is click the settings button, press table. Now I can enter any, I don't know why you'd want to burn your chicken to a roast at, no, 353 at mark 16. That's, oh wait, this is Celsius. So this is probably like super like 600 degrees, which you'd never cook anything at. But if we're going back to the question, if I put in 10, bam, 258.1. So it is reasonable. Um, so I'll write some of that in here, here, oops, here. So I'll put here, um, yes, it is reasonable. Okay, so I guess for the remaining of most of the class, I want you to try to put in this data. So you got different fruits, their energy in kilocalories, and then their carbohydrates, and then over here it says 100 grams serving of avocado is 161 kilocalories. So yeah, everything's in 100 grams. So basically, you're just going to see it does 161 kilocalories. They always say avocados are like superfoods. That's why Tom Brady loves his avocado ice cream. But anywho, 161 kilocalories. And then you want to see when you type that into your Desmos or into your equation, depending on how you do it, does 7.39. Does that make sense on your trend line? Um, yeah, so yeah, just to kind of show you now, I feel like I'm overdoing it, but if I copy down this equation again here, here's another way if you wanted, if you just had the equation from Desmos, which is here. So I'm just going to copy it down. Y equals 13.6x plus 122.1. So now that I have it on my paper, another way to check it, if it's reasonable, because X is your gas settings, you could just do in your calculator 13.6 times 10 plus 122.1. And then C, that should come out to the 258, blah, 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 that way. So same thing down here. I think your kilocalories are your X and your carbohydrates are your Y. So that is a long video. That should definitely get you going. And then you can take the, again, so all you're doing for the rest of the class, you're trying 6, you're trying 8, you're trying to make on Desmos number 11. Then you can do your best to fill out your data surveys. And I think that will be good for today. I don't know if I'll have you do this page. If you don't see this page in your packet, it's because I decided not to do it. Have a good day.